Hello and welcome to another tutorial. So this time around, going to be making a couple of small additions to the Behaviour Trees package. So this is a standalone package from the AI behaviors one that I've been working on of late. If you've been watching recent videos, the Behaviour Trees side of things is something I am going to eventually be rolling into that main AI package. But before I look at doing that, there were some small sort of additions that I wanted to add to the current setup to sort of round it out. So we're going to dive on in and take a look at getting that up and running. So things that I want to add in is, one thing is I want to be able to have a node that just sort of demonstrates forcing a return result, because that's a useful thing to be able to see how we can work with that. The big thing though that I want to focus on getting implemented is the ability to have a node that runs two branches in parallel. So this can be really handy if you're wanting to have two essentially separate behavior trees in many ways running in parallel. So you could have one behavior tree that is focusing on doing movement, and it's the driving tree, but then in parallel to that you actually have a second tree that could be doing other things like looking around, vocalizations, things like that. So that's what we want to get up and running. So I'm going to focus on that parallel side first, but I'll create both of the scripts to begin with. So I'm going to have a BT node, and what this will be is this will be parallel. And then we're going to do another one that is a BT node, and this is going to be our return result. So those are the two ones we're going to be working with. There will be other ones that we do need to update, things like that. So we don't want the action one there, we want the parallel one. And we might end up making modifications to the action one. So, okay. The parallel one I'm going to look at first because it is the most involved. So key initial thing has to be based off of node base. That's starting point there for this. So, okay, it's going to have two branches, a primary and a secondary one. So I do need to keep track of that. So I'm going to have a protected, and we'll have primary child. And we'll also have a secondary child. So the primary one is the one where its success or failure determines whether the secondary one keeps running. Now, with that secondary one, we might want to, if say the primary succeeds immediately, we probably want the option to still run that secondary child there. Or we might want to have the option to not run it. So that's something where what I want to actually do is I'm going to have a serialized field, and actually it doesn't need to be serialized field. We're just going to have a bool, and we'll call that always run secondary. And I'm going to default that to true. So the default behavior will be that the secondary node or secondary branch will always get run at least once. So that looks good so far. We're going to need to be overriding a bunch of functions for doing things like the adding and so forth. So if we go to our node base, these normally, we have our add functions here, and they would normally be populating our set of children. So I actually want to prevent that. So what I'm going to do is I'm going to grab a copy of these two functions, and I'm going to paste them in here. I will delete the contents. Now you'll see it's giving me errors here, partly because I'm not returning, but it's also going to be unhappy because I'm essentially eclipsing the functionality in the parent class. So what I'm going to do is do public new, because I'm wanting to completely just stomp the behavior of the parent class. And then I will actually throw a new, and we'll have invalid operation exception. And in this case, add is not permitted with BT node parallel. Use set primary or set secondary. So we give a nice clear error. So we both highlight, okay, this is the thing that's not able to be done, and we also give details on here's how you actually go about fixing it. So that's good. So the reason for this is because we're not maintaining a list of children or an array of children. There is only a single one. We want to keep the complexity of this from ballooning out. Doesn't mean that we couldn't, under this have a selector or a sequence node or even another parallel node. That's fine. The key thing is just that there is only one primary and one secondary that's attached to this. That's sort of the big sort of thing with this. Then what I'm going to do is set up my BT node base, and this will be my set primary. So that comes in the new node, and we do the restriction where that has to be a node base, or has to be based off of node base. So we can go primary child is equal to that. We return primary child. Set secondary is actually going to be, unsurprisingly, very, very similar. The only thing that changes is we access the different variables. So, okay, that gives us, we've gotten rid of the ability to do add, and we have given it the ability for us to set that primary and secondary one. So that's good so far. Now, we actually kind of need to override the tick behavior. And if I go to our node base, there's actually a few changes I want to make to this. So it wasn't something that was causing an issue, but in terms of how the tick works, I actually want to change this around so that the main tick one here does actually return if it ticked any nodes. And then tick services, I'm going to make that public. And I'm going to need to do the same with our evaluate decorators because we need to be sort of running these externally. So the main reason I'm adding public for these is so that I actually have access to these when I'm setting up calling of them in node parallel, because I have to kind of override a lot of the tick behavior because the actual tick behavior is pretty significantly different for that parallel node. That's really sort of the big thing that we're running into there with this. So then, okay, with this, what we can do is if we go and take a look through how we were actually ticking stuff before. So we were doing our ticking here by running on tick. So what I'm actually going to do is make that so that it runs that parent tick function. That's just going to make things work better with our parallel setup, means that we're running sort of the full logic for it. And I also need to make this one public because that's actually some common logic that we're going to need for all of them. And that, because it's grumpy, I need to make this public as well. Might mean there's a few things grumpy at me, but that's okay. We'll be able to easily fix those ones up. So not surprisingly, anything else using the elements. So this is kind of an artifact of the architecture for this. So when I do bring this over to the AI behaviors package, I do have plans for some improvements in general to the architecture for it that'll make it so that we won't run into these same sort of issues. So, okay, we can now override our on-tick behavior. So, on-tick. So what we're going to do with this is, okay, well, if our decorators don't permit us running, so if the decorators are not permitting running, then our last status is that it's failed. We are going to keep track of if we ticked any nodes, which will default that to false. So if this is the case, then what we do is we just return ticked any nodes. Now, in this case, we have actually, although we haven't ticked the children, we have ticked this node. So I'm going to say that yes, we have actually ticked it. Then what I would do is tick services. So do that. Right down the end here, I'm going to return the ticked any nodes as well. So, okay, we've checked if the decorators don't allow us to run. If they don't, then we'll go and tick any of the services. So then, okay, well, firstly, let's check if the primary child is null. If it is, we should actually fail out. In this case, I just return false. So I want to force it to be that we haven't actually ticked anything. And I'm actually going to check that before I do any ticking of services. Then what I want to do is, okay, that primary child, decorators for it might have actually changed for whether they can run or not. So, okay, I want to keep track of primary was enabled. So it was enabled if the primary child, and then we can check decorators permit running. Then we check if it is enabled. So we're specifically looking for changes that are happening here. So we tell it to evaluate the decorators. Now the reason for this is if we were not enabled and we now are. So essentially we're trying to catch the fact that it has been enabled after previously being switched off. Then what we do is we reset that so that branch gets entirely restarted. So this just means that when we're working with this, that it's in a very predictable state. So if that branch, decorators shut it off, or maybe something had caused part of the branch to be flagged as failed, then we do a full reset on it so that it actually can properly run and properly evaluate itself from scratch. So then now, if the primary is enabled and ticked any nodes, or equals that, we do primary child tick and our delta time. Otherwise, our last status is that it failed. Now we're going to check, okay, should we always run the secondary? And do we actually have one? So unlike with the primary, I don't want to make it mandatory to have a secondary node linked up. But if it is, then I want to actually process it properly. Should we run a secondary? Is one present? Primary child is now enabled. Cool. Now newly enabled. So, okay, for this, the logic is actually going to be similar again. I want to do this logic here, where, okay, let's change this to secondary, because it should follow the same principles. If it was previously switched off and is now re-enabled, then we want to do a reset on it. Save that, so that's good. And then all we do is if secondary is enabled, then this can update. Actually, we don't want to update ticked any nodes for this. We want primary one to be the driving one for that. So the idea is that the primary dictates the status. So what I will actually do here is last status is primary child, last status. So the primary child dictates the status of this. So if the primary completes, then we've completed. If the primary fails, then we have failed. If we, no matter what happens with the secondary, it'll just continue to restart itself if need be. So that looks good. So then what I need to also do is a couple of other things to override. So one of the ones is I need to public override so our reset. So we can still run the base reset. And then if primary child is valid, we reset it. So a reset to this node barrels down to any of our children. So that's good. The other one, and we did see this briefly appear, is we want to also override get debug text internal. So in this case, I'm not actually going to run the base one, but I am going to go and grab the base logic that we would normally do. So the reason being is I'm not processing any of the children. I want to control sort of the formatting of this. In theory, yes, I could let this run in that I'm blocking children being added and only rely on substituting in the base logic. The reason I'm not a fan of doing that in this particular case is it's kind of, I am wanting to really sort of override the behavior here, and I think it makes most sense in this case to duplicate it. This one's going to be largely the same, but this just is going to do primary child, and it's just going to check if primary child is not equal to null. So we only want to be adding that in if it's not null. And then we do a similar thing for the secondary child. Good. So, okay, we have our debug support, all the basic logic there for the parallel one. In terms of how we use it, so if we go to our BT setup, where we've actually got a basic sort of tree being created, we can kind of see there for how we go about actually adding to this. So what I'm going to do is if we head down to where I'm setting up these services and everything like of that. So I'm just going to, with our wander one is actually what I'm going to modify. So at the moment, wander adds this sequence, and then what it does is it has the actual perform wander logic under it. So what I'll do instead with this is we're adding the sequence, and then I'm going to add a BT node parallel, and then I want to actually call that wander logic. And we make sure we actually turn that like that. So as a BT node parallel. Then, so what I want to do is go, okay, well, wander root, I need to set the primary. So the primary is going to be a new BT node action. And then I want to be able to pass in these initialization functions and everything to this. So this is going to change to that. So we're passing in everything. And then I want to, in parallel to that, do a set secondary of another BT node action. And this is just going to be a random yell. So it's just going to randomly be yelling out, is the goal with this. So what it's going to do is its return is going to be that it succeeded, which is fine. And then its actual action that it's going to do is, we'll get to this in a second, so what it will have as the action, and I'm going to create a variable up the top here for a yell cooldown. That's good. So, okay, our actual yelling logic, what I want to do is yell cooldown, and we subtract from that time delta time. And very familiar logic, if that's less than or equal to 0, debug log, I am wandering that. And then we just reset the cooldown. So that's going to be a random range. Now, because we've got system included, that messes up with things. So I'm just going to get rid of that being directly included. I usually try to avoid having it directly included. So a random range, and we'll say between 1 and 3 seconds. And we just need to return that it is in progress. Actually, that one could return succeeded as well, I think. Actually, this would be the in progress one. But when it actually has done it, and it should just actually be in progress for both. So that's good. Now, things are grumpy at us because we're creating actions in this manner. So we actually need to, in our BT node action, need to have a BT node action. And we're going to have name. So all of our standard sort of parameters that can be passed in, we're actually using all of the parameters that are here. We go to our add function. It's actually all of these. So what I will do, copy those over, just because it makes it easier, means that it properly matches the setup. So that's good. So what we do then with those inputs is we pass those into the base constructor. That so on enter function and on tick function. So that's good. That should make it happier, which it seems to mostly be. Now, because we've gone and added in that constructor, what that does mean is we have to make a slight change for all of these ones. So these all now need to get modified for using the actual newing of the particular logic. It's just kind of a side effect of having created the constructor. We have to actually work with it a little bit differently. So that's good. That means we should in parallel be having it actually run, and it'll periodically yell out. We should see that appear in the console. Okay, so if we test this out, what we should see is while it's wandering, it's going to be performing that random yell. And then now that it's chasing us, we won't see that be continually output. Now, it does tend to bump into us. Now, the reason for that is we want to give a bit more of a stopping distance here from the agent. It was trying to move exactly to the target. The problem with that is that means it's essentially trying to head to right within the player, which is less than desirable. So yeah, no output of the wandering at the moment until it loses tracking of us. Once it loses tracking of us, then we should see it return to start doing the random yelling. So chase is still valid. We're far enough away. There we go. So wander is back valid, and it's back outputting the wandering message. So that's good. So our parallel mode is working. That's running the two branches independently. Well, two branches at the same point in time. So that sort of really expands our options in terms of logic that it can be doing. Now, the final thing that I did want to implement, just because it can come in handy, is this return result one. So I have our BT node base, and then all I would do with this is have our behavior tree node status, and this is our status to return. So we'll default that to succeeded. Then we have a protected override void on enter. And all this is going to do, it'll run the base on enter, but the last status then gets set to that status to return. I will also set up here, just so we can easily be adding into things, a public BT node return result. We'll allow the name to be overridden, but nothing else. And then what I would do is, okay, we'll base f our name, so null or empty for name, then I want to provide through result. I can actually put that as the particular status to return. Now that might actually be a little bit more than we're technically allowed to do in this. It does look like possibly that's the case. Yes, that is the case. So what I would do then in that scenario is I'm just going to modify this. So rather than doing that, do name like that. Just means that we can have appropriate sort of result there for it. What I can then do is as a test, okay, we could put this temporarily in here. What I could do, I'm just going to do a return for now so we don't run that. And we do a wander root, set secondary, new BT node, and result. And really kind of doesn't matter what we actually put in there for the particular name, because actually what I want to do is override this. That looks good. So do this. And we'll just return in progress for now. So, okay, let's test that out. Mostly what I'm looking is to see, okay, what's the debug result look like? Because the debug here, so yep, it's continually returning for in progress. What I would do is also modify this. So as well as overriding the onEnter, the actual other one that I should override is the onTick. So we'll let it run the base one. We always return true. And what I would do is, because the last status, I need to override it. I don't want it to actually be getting changed at all. So we'll run this. And so what we should notice now is before we were getting a lot of flickering with the in progress one. Whereas now we don't actually get that flickering because the state is actually succeeding. So that's good. We have extended our behavior tree system so that we now have support for running things in parallel, so that we have the ability to actually have a node return a specific status, which can be useful for at the end of complex conditions. We've also made it so our AI doesn't stop directly in the center of the player. So all useful additions that we've added there for this. So dive on in and experiment with this. As I said, there are going to be further updates that I do with this, but those updates won't be in this branch and in this project. What I'm going to be doing is incorporating the behavior tree system into the AI behaviors package with the goal-oriented action planning setup. So it's going to get blended into that. So the one package will provide a range of different methods of working with different AI behaviors. And it'll be kind of a one-stop shop. So that's going to be on its way soon. And yeah, I will link that in this video once that's actually out. Thanks, folks. Hope you found the video interesting and helpful. If you have, chuck in a like and subscribe. Really helps out. It's really appreciated. If you have any questions, chuck those in a comment below. If you're looking for the code for the project, that code is available up on GitHub. I've put a link to that in the description. The code is free for you to use in any of your own projects, commercial or non-commercial ones. And until next time, bye.